Hi everyone, this video is going to take a look at the three different types of formulas that we can use to describe organic compounds. There's lots of terminology that you're going to see in regards to formulas. A lot of times you'll see references to molecular, empirical, and structural formulas. These are three ways that we can essentially describe different types of molecules. So let's say you're given a molecule's name like hexane. You know, using your reference tables and using your knowledge of hydrocarbons, that structurally hexane has 6 carbons, 3, 6, all linked by single bonds, denoted by the ANE, saturated alkane ending. So structurally, hexane looks like this. And this is called its structural formula. Structural formula isn't really much of a formula. It just tells us how we represent the molecule in 2 dimensions. So this is its connectivity of atoms. Its molecular formula tells me what atoms were used to build the molecule. So we have 2 different ways that you'll sometimes see that represented. We can condense the structural formula to show that this molecule is made up of a C attached to 3 H's, which is then attached to a C with 2 H's, which is then attached to a C with 2 H's, another C with 2 H's, another C with 2 H's, and finally a C with 3 H's. This is its condensed structural formula. When we ask for molecular formula, though, what we want is the most condensed version of the atoms that build this molecule hexane. So in sum, we've got 6 carbons, so C6, and 14 H's. And that's its molecular formula, C6H14. Finally, we have something called the empirical formula, which doesn't really tell us a whole lot about the structure or composition of the molecule, but it does tell us the lowest ratio of carbon to hydrogen in that particular compound. Now, we don't necessarily use empirical formulas exclusively for hydrocarbons, but we follow the same general procedure. What's the lowest ratio of all of the elements in this molecule? And what I see here is that 6 and 14 are both divisible by 2. So when I go from my molecular formula to my empirical formula, I'm going to try and divide by the greatest common factor that exists between 6 and 14, which in this case, I believe, is 2. So if I divide by the GCF, which in this case is 2, what I'm going to get to is a C3H7. Now, if you try to draw a C3H7, you're not going to have much luck because this empirical formula only tells you that for every 3 C's in this compound, you're going to find 7 H's. So it doesn't give you much about the structure, but it does give you a little bit of hints about the composition of the molecule itself. For us, that's not entirely useful, except for when we get problems that look like this. If you're given a molar mass, in this case, we know we've got a hydrocarbon, and we know its gram formula, or molar mass, is 84 grams per mole. We're also told that it has an empirical formula of CH2. So what we're essentially trying to do is go from an empirical formula back up to a molecular formula. We need to figure out what we need to multiply by to go from our empirical to molecular form. So what I'm going to try and do is figure out the mass of my empirical formula and figure out what I need to multiply to get that mass up to 84. So on your periodic table, what you're going to find is that C weighs 12 and each H weighs 1. So 14 grams per mole is my mass for CH2. I want to change 14 into 84. So if you use your calculator, 84 divided by 14 is going to give you 6. So I know that I need to multiply this times 6 to get up to a mass of 84. That's this step right here. I'm going to multiply all of my subscripts in CH2 by 6 to get back to a molecular formula. And when I do that, I end up with C6H12. Using your general formula on table Q, what I'm going to notice is that fits the general formula of an alkene molecule. So 6 carbons is hex, and then knowing that it's an alkene makes it an ene. The only problem with this name is that I don't know exactly where the triple bond is, so technically this is kind of a trick question. There's going to be some number out in front. We would have to be given a little bit more information to figure out what that number might be. But that's the general idea. We got to go from an empirical formula, figure out what I need to multiply to get up to that mass, and then do the multiplication. This is our end molecular formula. You could then hypothetically transfer that into an IUPAC name if you have enough information to do so.